All right, as we begin week 4 in this exciting time looking at biological molecules or biomolecules, we want to start and begin this exploration by looking at the building blocks and their relationship to macromolecules. So we look at that term macromolecules. It means large, big, huge molecules. To build them, we start with smaller components. So we're going to explore this idea first. That will lead us into a better understanding of each of the 4 types of biological molecules. So as we begin, I want to focus on carbon. So we should all remember carbon. We went through a little introduction into chemistry, into building atoms. So we should have a good idea of what carbon looks like. In terms of living systems, carbon has very, very important properties. We are all carbon-based life forms. So with that, you've probably heard of the term organic molecules. Organic molecules basically means carbon-based molecules. The question you might be asking is, why is carbon so important? What property of carbon makes it so important to building these biological molecules? Now, if we remember back to building atoms, we should have this memory that carbon had 4 valence electrons. Remember, we had 6 protons, 6 neutrons in carbon. There were 2 electrons in that first orbital, and then in the second orbital, we had 4 electrons. To fill that valence shell, we needed a total of 8. Since there are 4 remaining electrons needed, carbon can form up to 4 covalent bonds. This is what makes it so cool, so exciting. This is what you need to start understanding. What this allows carbon to do is form big, long chains. And when it forms those chains, that's going to take up 2 of those bonds, leaving 2 more bonds left over to form branches and make these molecules start to look unique and different. So we can look at a carbon atom that's bound to 4 hydrogens. This would be methane. As we start to form long chains, we can have these branched hydrocarbon chains that can look something like this. These are long chains, branch chains, and it's because carbon can form up to 4 bonds, can make chains of carbons with other things extending off of them. So as we continue to look at carbon, whenever we see a carbon bound to hydrogens, we call this a hydrocarbon or a hydrocarbon chain. Carbon with attached hydrogens. These molecules are actually pretty boring. If we remember, carbon-hydrogen bonds are nonpolar. Carbon and hydrogen have basically equivalent electronegativities, equivalent poles for electrons. This makes them what we call hydrophobic or water-fearing. They don't interact well with water. We should all understand at this point, as we've been talking about life, that life is based on water. So we need to find some way to make these hydrocarbons more likely to associate with water. So that's where we're going next. So we have these hydrocarbon chains. This is our starting point. Started with carbon, built chains. And so we look at these and now we want to start making these carbon-based molecules, these organic molecules, better for life. So the organic molecules, their properties depend on the size and shape of the molecule, how many carbons, how many hydrogens, how many other atoms are associated with them. Along with just simply the size and shape, we add groups of atoms called functional groups. These are attached to that hydrocarbon chain. So remember, hydrocarbon chains by themselves are not soluble in water. Therefore, we can add these functional groups, which add new characteristics to those hydrocarbon chains. This is unique, this is exciting. So this is a wow moment. It can make them hydrophilic. Hydrophilic basically means water loving. And being water loving, they become soluble in water. This is a necessary prerequisite for their roles in water-based life. makes them soluble, makes them hydrophilic. It can also potentially make them more reactive. To build chains, to build big molecules, they have to be able to react. So these functional groups add new, important, and interesting properties to organic molecules. So we can look at a couple functional groups. There are many different types of functional groups. We're just going to identify 3 of them that we'll notice throughout the biological molecules that we look at. So you want to recognize these. There are 3 that we're going to look at. These are attached to hydrocarbon chains to add these new properties. These new properties we call hydrophilic, and make them soluble, make them more reactive. So we can look, we'll notice as you go forward, you'll notice carboxyl groups or carboxylic acid groups. You'll notice amino groups. Both of them you'll notice in proteins when you start looking at the biological molecule protein. The phosphate group, you'll notice that in nucleic acids. You'll notice that in phospholipids. So you'll see some of these functional groups over and over again within the biological molecules. So keep these ones in mind as you explore the biological molecules in your future videos and future parts of your assignment. So we've taken these carbons, we've made chains, we've added these functional groups. From there, we can start to build what are called monomers. So we have this unique arrangement of organic molecules and functional groups to form monomers. The term monomer simply means single unit. We take these single units and put them together to form polymers. So this monomer is just a very generalized name for the individual units that are put together to build polymers, which is another general name for these large macromolecules. So we can think of monomers, we'll use this analogy, we can think of monomers as individual letters. When you take those individual letters, we can call them the monomers, when you string them together, you can make words, sentences, stories, books, whatever you're looking at. So we can take the letters OIL, OG, BY, those are the monomers, and we can put them together to make the word biology. That would be the polymer. Another example could be something like a pearl necklace, where you have individual pearls, these are the monomers. When you string those pearls together, you can make a pearl necklace. This would be the polymer. So you can see a nice, beautiful, elegant pearl necklace here. Very importantly, each type of biological molecule, the 4 that you're going to look at, has a unique monomer that is used to build it. So monomer is just the general term. As you start looking at those different biological macromolecules, remember that each one has a specific type of monomer associated with it to build that polymer. So let's start looking at biological molecules. Took those carbons, put them together, made hydrocarbons, added functional groups, made these monomers. Now we start building them, putting them together to make the polymers, the biological molecules. These biological molecules, as you've probably already heard me refer to them as, can also be called macromolecules because of that large size. We might even also call them polymers because they're many units strung together from these identical building blocks called monomers. Polymers are built from many monomers with the help of enzymes. So enzymes are out there, these facilitate chemical reactions, they help to build these long chains, these polymers. There are 4 classes of biological molecules that you'll explore in future videos and the rest of the material that you're going to go over in this week 4 assignment. Each biological molecule, remember, has a unique monomer to build it. So the 4 that we will look at and the 4 that you will explore are going to be carbohydrates, proteins, lipids, nucleic acids. Some of these terms you've probably already heard of a few times through nutrition, through food, proteins, carbs, fats. These are the macromolecules. These are the important biological molecules. Where do we obtain the material to make these biological molecules? You get it from the food you eat. So it does kind of mean the same thing as when you hear about it in nutrition and food. To build these, the last couple of things we're going to talk about is how we're building these macromolecules and how we can break them down. So importantly, we have those monomers, we need to link them together. To link these macromolecules together, to link the monomers to make the polymers, we perform what are called dehydration synthesis reactions within our body. The reason they're called dehydration, you look at that word dehydration, you're out for a run, you're sweating, you're becoming dehydrated, you're losing water. In this reaction, you'll notice this short polymer chain. When it wants to add, or when you need it to add another monomer to it, an OH or a hydroxyl group, which is another functional group, is removed along with the hydrogen. You need to break bonds that are currently there to form new bonds. When these molecules, when two H's and an O come off, that forms water and allows us to link that monomer to the growing polymer. This makes a 1 unit long polymer. This reaction is facilitated by enzymes called a dehydration synthesis reaction. Now, if you want to do the opposite, let's say you want to take this polymer and break it down to individual monomers, which we need to do inside of our body. If you think of digestion, digesting these long polymers, when we're eating food, when we're taking in food, we need to do the opposite of this. So if water comes out when we're forming these polymers, water will need to go in when we're breaking them. So polymers are broken apart by what's called hydrolysis reaction, the addition of water, once again facilitated by enzymes. So water can be added, enzymes are used to break up these polymers into smaller components, breaking off monomers one at a time. So this is all we're going to explore in this chat. What you should be able to understand is and be able to summarize the following ideas. What are organic molecules? What is the importance of functional groups? Summarize the building of the polymers from monomers. This is a generalized idea. And compare and contrast this dehydration synthesis reaction to hydrolysis reactions. This is what you should be able to do now. This is that first part of your assignment. So answer the appropriate questions in that online handout. Move on to the other online material which focuses on specific biological molecules, their structures, and their importance to living systems. So that's all I have to talk about in this chat. Good luck and work through that online assignment, and we'll talk about it when we get to our face-to-face chat. All right? Goodbye.